So next, let's do problem 53, which is sine x cosine 15x minus cosine x sine 15x. Now that sounds familiar. So let's look at our formula chart. Okay, now I made. Let me show you the formula stuff. You see, I took screenshots of all the formulas in the book and packed it all into one page like this, so that I can look it up easier. Okay, and out of all this stuff, check which one that looks like sine A cosine B minus cosine A sine B, and I can see one right here. See, right here, which you see sine alpha cosine beta minus cosine alpha sine beta. And that is exactly this situation. See, sine alpha cosine beta minus cosine alpha sine beta. And what does that equal to? That equals to sine of alpha minus beta. Oh, so let's do that. So that equals to sine of alpha, the first one, x minus beta is the 15x, the second one, which is equal to sine of negative 14x, and that is which equals to negative sine of 14x. Okay, that is because sine is an odd function, so the negative sign has to come out. All right, so with that we have, let's see, 53. That is correct. Okay, upon checking the answer at the back of the book. So next, let's do problem 56. Which is sine 6x plus sine 4x divided by sine 6x minus sine 4x equal to tangent 5x cotangent x. And we need to prove that this is true. All right. So being that this is a sum, right, a bunch of sums, and then it turned into a product on the other side that we're trying to prove. So let's look at the sum to product formula and see if we can get something out of it. And so here's the pack of sum to product formulas. And which one should we use? This is sine plus sine and sine minus sine. So let's use the sine plus sine and the sine minus sine one, which is the first one and the second one. Okay, so let's do that. Now first, sine alpha plus sine beta equals to 2 sine of the sum over 2 times cosine of the difference over 2. So let's do that to the first one. Okay, so that equals to 2 times I'm using the wrong marker or something. Now, give me a second here. All right, this is equal to 2 times the sine of the sum, okay, following the formula. Sum of 6 plus 4 divided by 2, that is 5x. And then cosine of the difference, cosine of sine alpha minus beta, that is 2x. All right, and then divided by the other one is a sine minus sine situation. So let's look at the formula again. Sine minus sine is equal to 2 times sine of the difference, and then cosine of the sum. Okay, and then divide by 2. So let's follow that plan. And so that would be 2 times sine of the difference. Sine of the difference. So will be 6 minus 4, that's 2x. And then divide by 2. Did I divide by 2 here? No, I did not divide by 2 in this case. This is supposed to be, because 6 minus 4 is 2, and then better not forget to divide by 2. So it's just x, okay? And similar to here, this is 6 minus 4 is 2, but we have to divide by 2 according to the formula. That is 2 sine, and the difference, okay, the difference, and then cosine of the sum. So cosine of 5x, because that's what we had before. See, 6 plus 4 divided by 2. So we got to here. Okay, so what does this equal to? This equal to, so sine, we have the 2 cancels out, so let's ignore that. Sine 5x over cosine 5x, that would be tangent 5x, okay? Because sine over cosine equal to tangent, as we say right here. Opposite divided by adjacent. Sine over cosine is tangent. And the other, let's take care of these two. And then cosine x over sine x, that's 1 over tangent. Okay, that's the opposite, which is 1 over tangent is cotangent. See, they are 1 over each other. So this is a cotangent x. See, they both have the x. So that is cotangent x. And the only reason we can do sine 5x over cosine 5x because they both have 5x. And if they're different, then you can turn them into a tangent. Okay, it has to be the same angle. But anyway, now you notice they are exactly the same. So we are done with problem 56. Next, let's do problem 61, which is cosine x minus cosine 3x equal to 4 sine squared x cosine x. All right. So again, we have the situation of some kind of a sum or difference here. And the word sum includes difference because difference is just like sum except you're adding something negative. So then let's look at something that's cosine minus cosine out of the formulas. So staring at the formula, which one's cosine minus cosine right here? So let's try that, okay? So cosine alpha minus cosine beta equals the minus 2 sine of the sum and then divided by 2, and then sine of the difference divided by 2. So let's follow that formula. This is so the left-hand side that equals to minus 2 sine of the first one will be alpha and the second one is beta, sine of the sum divided by 2. So that is 2x and times sine of the difference divided by difference is x divided by 2. That's minus x. All right, so that is just the left-hand side. And then, of course, the minus sign comes out over here. It cancels out with this one, so we'll keep it as a plus. Okay, is that right? All right, so we have 2 sine 2x and then sine x. That doesn't look like that, though, so we need to work on it a little more. We have a sine x right here, okay, sine x, but that has another one. But there's nothing about sine 2x. So let's do something to this thing. So that equals to 2 times sine 2x has a first formula, and that is frequently used. The double angle formulas on the side, okay? And double angle formula sine 2 theta equals to 2 sine theta cosine theta. That is sine 2x, just this part, equals to 2. Here, so here's 2 sine x cosine x. Sine x cosine x. That's following the sine 2 theta formula. And that 2 is over here. This is a new 2 that comes from sine 2x. Becomes 2 sine x cosine x. And then there's another sine x right here, which we will put it right here as a power. And you notice this is exactly that. Okay, this is equal to the right-hand side, and we are done. So that's that. For problem 61, next, let's look at problem 62, where we have cosine of 2x minus cosine of 4x squared plus sine of 4x plus sine of 2x squared. And to show that e equals to 4 times sine squared 3x. Now, I don't have the 2x and the 4x in parentheses because to reduce the amount of writing. But just for this particular video, remember that these things are actually in parentheses. So cosine is not just cosine of 4, but cosine of 4x, okay? And the others are the same. And anyway, let's see, to prove this thing, we have, well, again, this is some kind of a sum or difference. So let's apply those formulas again. That's what we've been doing in this little area here. This is cosine minus cosine, so let's apply the cosine minus cosine formula, which is cosine alpha minus cosine beta is negative sine of the sum times sine of the difference, and divide by 2 and stuff. So let's do that. So the left-hand side equals to LHS equals to minus 2, okay? This whole thing is in the parentheses, and it's going to be squared. So minus 2 sine of the sum, 2 plus 4 is 6 over 2, 3x. And then sine of the difference, which is 2 minus 4. That's minus 2 divided by 2 is just minus x. And then this is squared. All right. And then plus, that's just the first part. Next, plus the second part, this thing, which is sine plus sine. All right. So again, we look at the formula. Sine plus sine is right here. And that sine plus sine equals 2 times sine of the sum and then cosine of the difference and divide by 2. So following that plan, we have positive 2 times sine of 4 plus 2 is 6 divided by 2 is 3x. Yeah, cosine of 4 minus 2 divided by 2, that is 2, 1, just cosine x. That's also squared. Okay, that should be it. Okay, and so and now we just need to clean square stuff and hope that something comes of it. Let's see, what are we trying to do? We're trying to show that all this pile of stuff equal to this. Okay, let's see what it cleans out to look like. So that being that we're raising stuff to squared, the negative sign disappears. Okay, and so this, we can ignore the negative sign. 2 squared is 4, so we'll write down 4 sine 3x, that will be squared, okay, because of the squared. Sine of the minus sign comes out, but then it got squared, so it disappears. So it will be sine squared x, and then so that's the first part. And then the second part, similarly, plus 4. This is sine 3x, which got squared. Sine 3x. What am I talking about? Sorry. Sine squared 3x. Okay. Sine squared 3x. And then cosine squared x. Let's see. Cosine squared x. All right, so far so good. Now you notice that there is a common factor here of the 4 sine 3 squared 3x and right here 4 sine squared 3x. So whenever you see a common factor, let's take it out for no reason. Okay, we're just going to do it for the heck of it. So that equals to 4. This is equals to 4 sine squared 3x. That's taken out. So what's left is sine squared x, and then plus over here is cosine squared x. And now we have come to the Pythagoras theorem. Sine squared plus cosine squared, okay? And that is the one formula you must remember from trigonometry is sine squared plus cosine squared equals to 1. So that disappears into being 1. Then basically just you don't have to look at it. And so once that, so if this is 1, then the answer is 4 sine squared 3x. And that's exactly the right-hand side. So we are done. That's it. So next, let's look at problem 63, which says tangent of pi over 4 minus t equals to 1 minus tangent t over 1 plus tangent t. Okay, that's that. And so let's see how to prove that is the case. And to do that, first we'll dig out our formula pile and see if there's anything to do with tangent. And look around here. Okay, here's my formula pile. And look around this thing's tangent of a plus b right here. Okay, what's our problem? Oh, minus. We have tangent pi over 4 minus t. All right, so we'll look for the minus one. Right here, let's zoom in right here. Yeah, tangent of alpha minus beta. So I'm going to make it bigger. And that's big enough. All right, tangent of alpha minus beta equals to tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. So we'll plug that formula right in here, okay? On this thing right here. So this is equal to, first, to do that, we need to know what tangent of pi over 4 is. Tangent of pi over 4, here's pi over 4. Pi is 180 degrees. Pi over 4 is 45 degrees. And the tangent of 45 degrees, opposite divided by adjacent, is equal to 1. So tangent of pi over 4 is 1. Okay? So that is, what are we doing? Oh yeah, again, we're doing the tangent alpha minus beta formula, which equals to tangent alpha minus tangent beta, and then 1 plus tangent alpha times tangent beta. So following that formula, the left-hand side, that is this thing right here, equals to tangent alpha, tangent of the first one, which is 1, tangent pi over 4 is 1, and minus tangent beta, that's t, so it's just tangent t, and divided by 1 plus tangent alpha, which is again 1 times tangent beta, tangent of minus t. No, not minus t, just t, because we're following the alpha minus beta formula. So beta is just t. So tangent beta, which is tangent of t. And that is exactly the right-hand side. So, see? So, therefore, we are done, finally, with this section.